Hai, Assalamualaikum. Jadi pada lab kali ini kami akan cuba menganalisis macam mana apa yang akan terjadi pada, mari dekat sikit, pada rotor ni apabila kita brake. Jadi kita akan teruskan kepada kawan kita yang lain. Let's go.
Alright, so for the introduction, the disc brake has a metal disc or rotor instead of drum. It uses a pair of flat line shoe or pad that are forced against the rotating disc to produce braking. The pad has held in a caliper that straddles the disc. The caliper has one or more pistons with a seal and dust booth of it for each. During braking, hydraulic pressure behind each piston push it outward. This forces the pad into contact with the disc. The resulting frictional contact slow and stop the disc and wheel.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning to my lecturer which is PM Dr. Zahid and our classmate which is my group also. So today I'm AHMAD ID based SALMAN. My matric number B1922101003. So I'm going to continue about my presentation from my group which is for the disc brake rotor analysis. Okay, so for analysis, for my group teammates, Muaz also make analysis which is for the base material of iron. So I'm gonna change material which is I choose two example of material to be analysis also for the disc brake rotor analysis. Okay, so the first material I choose is aluminium and the second one is steel. Okay, for this one is the design of the rotor disc brake I have designed. Okay, so I'm gonna show about the result of the analysis. So starting with the material of aluminium. Okay. This one, the analysis of an aluminium. So the Young modulus of the analysis is 7 exponent 10 Newton meter squared, which is known as, we can conclude the 7 exponent power 7 power of 10 Newton meter squared. The unit is Newton meter squared. Okay, then next is Poisson ratio. Poisson ratio for aluminium material is 0.346 and the density is 2710 kilogram meter cube. Okay, next for the analysis is we got the coefficient of thermal expansion for aluminium is 2.36 power of 5 kilo degree. Okay, the important of analysis we need to know for each material is the yield strength, because yield strength will use we can use the yield strength to get the safety factor, which is the formula of yield strength. Formula of the safety factor, which is we need to divide the yield strength by the bond mistress based on the analysis of material. Okay, for the yield strength of aluminium is 9.5 power of 7 Newton meter squared, and the unit of the yield strength Young modulus is same, which is Newton meter squared. Okay, so that is for the first analysis. For the material I choose is aluminium. So the second material is about the steel. Okay, so for the analysis for material steel, the Young modulus we get is 2 power of 11 Newton meter square, and the Poisson ratio of steel is 0.266, slightly different to the aluminium, because steel is more density than aluminium, because steel is much tougher than aluminium. Okay, for density for steel is 7,860 kilo meter cube. Then the coefficient of thermal expansion is 1.17 power of -5 kilo degree, and the yield strength for the steel is 2.5 exponent 8 Newton meter square, Also, we call it as 2.5 power of 8 Newton meter squared. Okay, that's all for the two analysis for different material, which is aluminium and steel. Now, this is analysis for the this one is the analysis for the material of aluminium. Okay, this is the one mistress as shown as the slide. This is a one mistress analysis, and then this is a translational. This one is the frequency. Okay, that's for the aluminium. Sorry, this one is for the steel, and this one is for the aluminium material. So this for interest for the result on aluminium. This one is for displacement, and this one is the translational. So from the translational displacement, most of material we can play, and we can see the retro discrete analysis when we try to run the simulation. So I think that's all from me. Thank you.
Alright, Assalamualaikum, selamat sejahtera. Saya Muaz Zaini, nombor matriks P0922104331. Alright, so hari ni sekarang saya akan explain pasal bone meter stress dengan translational displacement. Okay, yang pertama sekali, berdasarkan lab sheet kita punya 4.0, dia ada minta untuk tengok dia punya before and after lah. Before and after dia punya, kita punya disc brake. So di sini bila animate, kita akan nampak lah di mana bahan yang kita gunakan ialah steel, kembang pada top value 108 dan lowest value 825. Seterusnya, untuk volumetric stress pula, di sini kita dapat tengok di mana macam mana keadaan translation dan displacement tu berlaku. Di mana dia ada beberapa bahagian lah sebab dia berputar, dan daya yang dikeluarkan, displacement yang terjadi dilihat keluar mengikut arah yang dapat ditunjukkan di sini. Seterusnya, dia punya unit adalah semua dalam Newton meter per second, dan untuk translational displacement pula dalam milimeter, di mana perubahan yang berlaku tu berapa milimeter. Itu saja.
Assalamualaikum, my name is AHMAD bin SYAHMI bin Ahmad YUSDI. My matrix number B0922104997. Okay, now I want to present about 4 of safety. As we can see, for the formula is strength divided by maximum bond mass. For the first material we use iron. For the calculation, 1.77 exponent 008 Newton meter torque divided by 1.08 exponent 006 Newton meter torque. As we can see, for the calculation, for the answer is 163.88.
Okay, next.
For the material, we use aluminium. For the calculation, 177 exponent 008 Newton meter torque divided by 1.72 exponent 011. For the answer is 0.00103. And last, we use material steel. For the calculation, 1077 exponent 008 Newton meter torque divided by 3.48 exponent 011. For the answer is 0.051. As we can see between these three materials, steel and aluminium are better than iron because the factor of safety for the rotor disc is 1.5 minimum. And last, that's for me. Thank you.
Assalamualaikum, my name is Muhammad HAIQALL. I want to share about discussion for this lab. The safety factor lowers the chance of a product failing and raises consumer safety. Safety is a crucial consideration when it comes to fall protection and safety gear. There is a chance of harm and death in addition to the company going bankrupt if a structure fails. On the other hand, this factor of safety is 1.5. This value pertains to under design. By altering the thickness, kind of material and radius, the safety factor can be raised. The braking system's safety factor is impacted by this rotor design.
Conclusion. Finally, we are able to complete the experiment for disc brake design and analysis. We built the disc brake in virtual reality with CATIA software and specify the material parameters of the disc brake rotor from the drawing. Finally, we using the disc rotor design, our group can determine the highest and lowest von Mises stress and transnational displacement value.